Hello everyone, welcome to Engineering Archives. Let's look at the first practice problem for the chapter Coplanar Forces. So this practice problem says, determine the magnitude of the resultant force and its direction measured counterclockwise from the positive x-axis. So from the diagram we can see that they have given us a set of x and y axes. But we notice that these axes are a little bit tilted towards in the clockwise direction. But you can see from the diagram that they are still perpendicular to each other. So we'll follow the same procedure. Just imagine as if this diagram is tilted a little bit counterclockwise, and we had the same x and y axes that we usually have. Okay, so let's put the directions first. Now let's find the components along the x-axis. So 400 sine of 30 degrees plus 250 cos of 45 degrees. And this will give us 0.8 newtons. Let's move on to the y-axis. For the components along the y-axis, we get 400 cos of 30 degrees minus 250 sine of 45 degrees, and we get 169.6 newtons. Finally, to get the magnitude of the resultant force, we will simply apply the resultant force formula. And we get 413.2 newtons. Now that we have the magnitude of our resultant force, we can find the angle that it makes with the positive x-axis by simply drawing the vector triangle. So we know that the sum of components along the x-axis is 376.8 newtons, while sum of components along the y-axis is 169.6 newtons. And we also know that the magnitude of the resultant force is 413.2 newtons. So we'll simply find theta using the trigonometric identity tan of theta is equals to 169.6 divided by 376.8, and we will get theta equals to 24.2 degrees. So this was the simple procedure for this question. Thank you very much. See you in the next video.